Good afternoon, all of you. In the previous class, we studied till lattice enthalpy and about Born-Haber cycle. And today we will be studying about a new type of enthalpy, which is enthalpy of solution, represented by delta SOLH. And the name enthalpy of solution itself tells you that it's some kind of enthalpy or it's a kind of enthalpy change related to a solution. So what is the solution? Solution is solvent plus solute. So when we add a particular amount of solute, for example NaCl, we mix it in a solvent like water, we get a solution. And that process, so mixing or making up of solution, whatever enthalpy change is happening, that is known as the enthalpy of solution. So definition of enthalpy of solution is enthalpy of solution of a substance is the enthalpy change when 1 mole of it dissolves in a specified amount of solvent. So this it means the solute or the substance. So enthalpy of that particular substance is when we take that substance in 1 mole, 1 mole of that substance when it is dissolved in a specified amount of solvent, then we can tell whatever enthalpy change is happening there, that is the enthalpy of solution. So like this, when we add some solute to a particular amount of solvent, we mix it, we make a solution, whatever enthalpy change is happening there, that is our enthalpy of solution. The only condition you should remember is that this 1 mole of the substance, the 1 mole of solute when it dissolves, that is enthalpy of solution. And one more definition you need to remember, which is of enthalpy of solution at infinite dilution. So it is an enthalpy change observed on dissolving a substance in an infinite amount of solvent when the interactions between the ions are negligible. So if you compare these two cases, I am trying to mix 5 grams of NaCl in this much of water. And if we mix after that, how the ions will be? Na and Cl ions will be inside this water, and there will be interactions between them also because it is nearby. So if one Na ion is there, here one more Cl ions will be there, and next Na ion. So like that, this water will be full of Na and Cl minus ions, and interactions will be happening there. And now I am trying to mix a 10 gram of sugar to this much of water, or into C I am going and I am mixing 10 gram of sugar to it. Will there be any change, or will there be interactions between the ions similar to in this case? No, because it's the dilution is infinite, or the amount of solvent is infinite. So much of water when it is present. So when I add 10 grams of sugar, so one ion will be here, another ion of sugar will be here. So that much of distance will be there when it is infinite amount of solvent. If it is not in the sea also, for example, if I take a bigger tanker lorry full of water and I am mixing sugar to that, will there be any change, or will there be any interactions between these ions? No, because it is an infinite dilution. So that particular enthalpy, which we tell as enthalpy of solution at infinite dilution. So when we mix a particular amount of solute in infinite amount of solvent, then we can tell that particular enthalpy change will be enthalpy of solution at infinite dilution. So it is the enthalpy change observed on dissolving the substance or solute in an infinite amount of solvent. So when that interactions is negligible, because as I told, one will be here, one ion will be here, another will be very far away. There will not be any interaction in this case. But unlike in this case, ions are nearby when there is finite amount of solvent present. The ions present are nearby and they will have interactions. So that is enthalpy of solution and enthalpy of infinite dilution. Now we will see an equation for enthalpy of solution. So enthalpy of solution is equal to lattice enthalpy plus hydration enthalpy. Both of this we have learnt. This we have learnt in this chapter, and this we have learnt in the chapter hydrogen. So how lattice enthalpy plus hydration enthalpy becomes enthalpy of solution? So we need to know the process of solution. So what is actually happening when we try to mix a solute in a solvent? We will take an example of NaCl only. So as we told, NaCl exists as a crystal. So in a crystal lattice it is existing like this, one Na ion then one Cl ion, like this it is existing. And when we mix into a solvent, for example water we have taken here, so when we mix it into water, what happens there? So as we told, we need to break down this lattice into ions. So when it is mixed into water, they break down to form ions. And what is that particular energy? That is lattice enthalpy. So yesterday we told, from a lattice when we get ions, the energy related to this breakage, or when one mole of lattice breaks down into its ions, that enthalpy is known as lattice enthalpy. So that is the first term which we told here. The solute ions are broken down into ions by use of lattice enthalpy. And now what's the term of hydration? So when we mix a particular solvent ions to water, there is a change occurring in water. This we have learned earlier also. So the linkage between the water molecules will have a weak interaction between them, and they lose that weak interaction, and when the ions comes inside, the positive ions of water molecules, which are the H plus ions, will interact with the negative ions in the solute. So in case of NaCl, Cl minus ions will interact with the H plus ions present in the H2O. And oxygen will have negative charge. Because of that, oxygen will form an interaction with the positive ion. In case of NaCl, it is a Na plus. So Na plus and oxygen will form an interaction, and Cl minus and H plus will form an interaction. So a cluster of H2O molecules will come around negative ions and positive ions. In case of positive ions, this side or the oxygen side of H2O will come to this side and it will make a cluster. And in this case, in case of negative ion, the H plus ion side or this side of H2O molecule will come and make a cluster around the negative ion. So this will happen in case of water, and this is known as the hydration. So this formation of cluster between or around the positive and negative molecules, this is known as hydration, and this process needs first the breakage of this small interaction between H2O molecules and then formation of interaction between the other ions. So all this needs energy, and this particular enthalpy involved with the hydration is known as hydration enthalpy. So after this, the solution is formed. So initially they should form ions, and that formation should need the lattice enthalpy, and after that the water molecules should interact with the ions which comes into water, and that is the hydration enthalpy. So both of them together we will get the enthalpy of solution, the lattice enthalpy and the hydration enthalpy. And in case of NaCl, how the cluster will look like? So this is how NaCl water cluster will look like. So Na plus will form a cluster like this, where the oxygen side will be towards the Na plus ion. In case of Cl minus ion, the H plus side will be towards the Cl minus. So like this the cluster forms, and this process is known as hydration, and the enthalpy involved in this is hydration enthalpy. For most of the ionic compounds, enthalpy of solution is a positive value and the dissociation process is endothermic. Why is that so? Why, when we have an ionic compound, why this enthalpy of solution becomes positive? This equation tells us the answer. So when we take enthalpy of solution, we are taking the summation of lattice energy and hydration enthalpy. And in this case, lattice enthalpy, when we told that the dissociation or the energy required to break this lattice and forming ions, we need to provide some energy to it, or we need to heat it. So then only this will break down into Na plus and Cl minus ions as an example. So that breakage needs energy or we need to supply. So that becomes a positive value and that is an endothermic process. So as this term is highly endothermic, we get this term also as a positive process or an endothermic process. So most of the ionic compounds which exist as ionic crystals like this, we need to supply some amount of energy to break down this. So that particular energy becomes endothermic and because of that we get the enthalpy of solution to be positive value. Therefore, the solubility of most salts in water increases with rise in temperature. So this we can tell an example which we do in our daily life only. So when we prepare sugar solution at our home, what we does? So we take sugar, we mix it with water and stir it well. After some time, how much ever sugar we add, it will not dissolve. So it will not dissolve in water and then what we will do? We will heat it. So we will heat the water, then start mixing more and more amount of sugar and the dilution will increase. That amount of sugar will dissolve in it. Why is that so? So when we increase temperature, more amount of sugar is dissolved because that process is an endothermic one. So as it is an endothermic process, when we give out more and more amount of heat, the dilution also is increasing. More and more amount of sugar is getting dissolved in the water. And that is the reason for why we heat the solution. If the lattice enthalpy is very high, the dissolution of the compound may not take place at all. So why is that so? When we take an ionic crystal and when the interactions between this positive and negative ions are very high, think that they are not separable, they are very strongly bonded together. In that case, the lattice enthalpy will be a very high value. So for example, if I am taking a compound which is very electronegative and other with an electropositive one, so they will have a high interaction between each other. And when they have more and more interaction between each other, they will be very strongly bind together. So we need very high energy to break them into ions. So if that is the case, as if we are not providing that much of energy to break down, then it will not dissolve only. So when we break this into ions only, it will dissolve. If we are not able to break this into ions, then how it will dissolve? So that's what told here. When the lattice enthalpy or the energy required to break this is very high, then it will not break down. So if it is not breaking down, the dissolution of the compound may not take place at all, or this remains undissolved in the solvent. And this is an equation which is connecting lattice enthalpy and enthalpy of solution. So when we have the value of lattice enthalpy and hydration, we can find out the enthalpy of solution. This is a part which is given in lattice enthalpy. So delta of solution is found out from lattice enthalpy which we calculated yesterday from the Haber cycle, and the hydration enthalpy from the literatures, or we are just referring it from some other books and we are substituting it in the equation. So we get delta solution or enthalpy of solution equal to lattice plus hydration, which is negative 784 plus positive 788. So that will give us a value of positive 4 kilojoules per mole. As we told, it is an endothermic reaction. A small amount of energy is required to form the NaCl solution. So that's all about enthalpy of solution. Now we will move on to the next term, which is enthalpy of dilution. It is a very similar term to that of enthalpy of solution, but we are doing dilution here. I hope all of you know what is dilution is. So we are adding solvent more and more to a concentrated solution. That's all the different. So enthalpy change or change in enthalpy when we add more and more of solvent to a concentrated solution. That's what we are measuring here. And how much is the enthalpy change as we add more and more of solvent? So this depends upon two factors. So the enthalpy of dilution depends on original concentration of the solution and the amount of solvent added. That is actually a simple fact. So I'll tell you an example. I have taken 1 liter of solvent and I have mixed 1 kilogram of sugar to that. So 1 liter solvent and 1 kilogram of sugar, and we are adding 1 liter of solvent to it. So that will be a particular change. And in next case, I am adding 100 grams in 1 liter. Initially, I have taken 1 kilogram in 1 liter, and now I am adding 100 milligram in 1 liter. And again we are adding the same amount of solvent, which is 1 liter. Will that be same? So concentration of the first one will be much higher than that of the second case. And when we add same amount of solvent to the two solutions, we will have different enthalpy and different change in that. So that is a known fact. And next is the amount of solvent which we add. So this also the same example we can tell. So I have taken 1 kilogram of sugar in 1 liter of solvent, and I have made that much of concentration. And first I am adding 1 liter of solvent more, and next I am adding 5 liter of solvent. In both the cases the concentration will be different and the enthalpy also will be different. So that's how we can tell it depends on the original concentration and amount of solvent. So how to calculate enthalpy of dilution? For that we have taken an example here. So HCl we are taken and we are mixing it with 10 moles of water. So we get the enthalpy change of negative 69.01 kilojoules per mole. And we have taken different conditions here. One system we have 25 moles we are adding to HCl, and next we are adding 40 moles. So in all the cases we are changing the amount of solvent which we add, and we get different values of enthalpy change. So we can tell that the amount of solvent we take is dependent on the enthalpy change. And in the last case we have taken infinity amount of aqueous solution or infinity amount of solvent we are adding. In that we get a limiting value which is very much negative. And if we want to find the enthalpy of dilution, for example if we consider this two, we want to find the enthalpy difference between these two, then we will get what is the enthalpy of dilution. So enthalpy of dilution we get from the difference between these two. So when we subtract one of them from the other, we get a particular amount of enthalpy, and that will be the enthalpy of dilution of this particular change. So that is the enthalpy of dilution. One of the enthalpy of dilution minus the other one, we get the enthalpy change between them, and that only will be the enthalpy of dilution of that particular change. So that's all for today, and tomorrow we will start with the spontaneity and about entropy and all. So prepare notes with help of textbook and submit it. Thank you.